Welcome to the CFD tutorial video, which I showed you in the class, but sadly that video was not able to upload because I lost access to the system. Anyway, so this is the Jeep we downloaded from GrabCAD, and we always need to reference it as Jeep 18. We'll go through the CFD analysis first, how to set up the external flow analysis for this Jeep, and then I will export the results from the CFD to the simulation analysis so I can show you how to perform some von Mises stress analysis. So we start with the flow simulation. This is a Jeep done. The model looks like okay, which you can use it for your assignment if you want to make something and modify it to optimize different things with this Jeep. Please reference the source of the GrabCAD and the creator for the model. So we click on the wizard. From the wizard, I'll call it Jeep 2 because I've done the model, CFD 2. Next, we have we are using the SI system units, but I prefer to change the velocity to kilometers per hour because we will set up the velocity of the reference air, which is the Jeep movement, about 70 kilometers per hour, which I explained the direction as well. We're not doing conduction, time dependence, that's for transit analysis, we're not doing that, but the gravity we could activate. So the gravity is showing me is going on the negative z direction, so we will give that 0, and we give in the y direction minus 9.81, and now you can see the arrow, it's indicating the direction of the gravity. Acceleration, we don't have rotation, we don't have free surfaces, and its analysis type is external. Geometry recognition, CAD, we leave it. Exclude cavities without condition, also exclude internal spaces, I'm not interested in that. Next, the fluid is considered air, so I will select air from gases, and then as well we'll leave that it's laminar and turbulent flow, and I will tick humidity here because we could consider the humidity of the air. Next, the system is adiabatic. I'm not concerned about temperature at this stage, and roughness is not internal flow, so I'm not concerned about that. Next, here is very important to notice that and following things. So the Jeep is moving in the x direction, but when I assume the velocity for that, it should be in the negative x direction because it's a reference point, so minus 70 kilometers per hour. And remember, we did change that in the SI system, instead of meters per second to kilometers per hour, which is that conversion will be managed by SolidWorks anyway. After I click finish, now you see SolidWorks will start creating for me the setup with the flow analysis. It's just take a bit time, and you can see it here. It's preparing the model. Now you see the computational domain is too big, which is kind of like the wind tunnel for this Jeep. It's too big and huge. I have two options, either to do it by values here, or I could do it manually and adjust them. I will do it both ways, so I can adjust that. That should be value of 0. That one should go to 4, and that one should go to minus 6, and that one I'll keep it 1.25. I would just change that value. The sides, I'm not really worried about them that much, so I could just shift them to minus 0.5, and the other one should be 0.5. 0.5 is possibly a 0.5, and then that one will maybe not 0.5. I will give it something in the middle, and if you want to see it better, you could select that due to the recording, the video is a bit slow, or the SolveWorks doesn't respond very nicely with the recording when you're recording this. I'll click OK. So that is the wind tunnel for this Jeep. Looks reasonable. I put too much height, it's just in case if there's something developed I can see it very nicely. I'll look to the goals, insert surface goals. But before inserting surface goals, I could hide the computational domain. In external simulation, we don't need to set up any boundary conditions. It's just taking the initial condition for the relative or reference velocity. So goals, right click on goals, insert surface goals. We'll select forces in the X direction. So search for forces. And then I'll select the following faces. Select as much as you can for the design you're interested in exploring. Okay, that should be sufficient for me at this stage, maybe the lights. However, I will exclude the lights from the FEA analysis and then click OK. That will be called the front forces. You can rename that, right click and rename, or F2, and then you can rename that. Another goal is forces for the back, so insert surface goals. We'll go as well force in the X direction, and then I'll select the following. As well as possibly not. If you have time, like, do as much as detail as you can, will be very helpful for the simulation to get more accurate results. But those tiny things sometimes, like, it's not essential to include them. I'm just including them at this stage, but it's not. Sometimes they give some results, changing results. All right. And also you can do another surface goal, which is if you want to calculate the lift coefficient. This would be forces in the, if you look carefully, in the y direction. So we look for the force in the y direction, and then we click OK. Alright, create a mesh, edit definition for the mesh. The mesh here is 3. I could make it 6. It will take a bit of time, but it's fine, and we can go and get the results. Now right click on the Jeep, you see it will pop up the window. The software start analyzing and prepare the model and meshing it, and then hopefully it will start producing the results. So first step is preparing model. See the blue indication, it's almost in the process, finalizing the process for preparing the model. And then mesh capturing, and now start performing the iterations. If the simulation would take time, I would just pause the recording, and when it's finished I will come back with the results, because it started now performing the calculations. And I'll show you the time it took to perform this calculation. So at the moment showing how much course is using. So I'll pause and come back. Alright, so now the solver is finished, and you can see all the results for the forces, front forces, back forces, and lift forces reached to the convergence, which is very good. It took about 206 iterations, and the time for that simulation, which I paused, is about 14 minutes and 37 seconds. So don't be surprised, as the video so far this here is 10 minutes and 37, but because I just paused the analysis. So now if we go, and you can see, because I run this as Jeep CFD2, you see it's generated for me 2.fld file. The cat plot, I will try to get a proper cat plot. You can see my cat or my plan is not in the right direction, so I'll try to shift it to make sure it comes really in the right direction. It's best to choose that one so you can bring it really in the middle, and then you can do vectors. We are interested in velocity in the x direction, and make this number as 100. Click OK. Let's see the results, how it looks like for it. And now explains to you why I extended that out for the Jeep, the computational domain, because if you can see, there's a lot of vortices could happen for that Jeep, which we are interested to understand. I could edit that and to ask it to show for me the streamline, and then click OK, and now you can see the streamline, how it's generated and how this is going in that direction for this Jeep. I also like to show the isosurface plot for this Jeep. I'm interested in velocity in the x direction, and you can see how this will be, the Jeep is technically exposed to the direction of the air when it's traveling with 70 kilometers per hour. Right, hide the cut and hide the isosurface. You can do float trajectory. What I recommend for float trajectory, you can always, instead of selecting it from those surfaces, I will go to the flow simulation analysis and selected that from the goals. So you can see here, I will just put this down and go to the surface goals. I will select the front, and all the faces we have selected, they will come automatically, and that's very useful to save time. And now you can see the results for the streamline. It's demonstrated, and then we can just play the video and we can see how it's going through it. Right, so that is one of the things. Now, as I say, please reference the source of the Jeep. You can technically now export this result. I will always come here and tools, flow simulations, tools again, and then export result to simulation. Till you get the message to say the following message appears to you: export is successfully completed, then this task is done. If not, then possibly this task is not done. Now click on simulation, new study. From this new study, I'll select static, and then from static study, just for the time purposes, I will select the entire object to be made of like alloy steel, but then I would change for the windows as we did in the class. So I'll come to the windows and I have this one. I will make it some plastic materials, acrylic, apply, and then I would do it for the other one. Right click, apply, close. Now I don't want to spend too much simulation. Well, my computer will not be able to cope with that much of details in the geometry, and also we need to create some proper type of connections between the assembly. So I will keep some of the parts, and if I want to do some simulation, I would just highlight the things I want to exclude from the analysis. So this one will be excluded, the chairs and everything would be tires would be excluded, and now you see what is left for me. The lights, I'm not interested in the lights, so exclude from analysis. So it left for me just the window shield to the body of the Jeep. That's sufficient for me. I'll apply a normal fixture, fixed geometry. I'll assume this is fixed to the remaining of the car. Okay, and then I will also bring the result from the CFD, and that's the step is very important. So you right click on external loads, and then flow effects. Here make sure you bring the second file or whatever is file. So you see I have two simulations here. It's going to the original simulation, but actually I have file 2, and I can bring the simulation from my second one. And that's very important if you're doing some optimization and you are changing something in your design. You need to bring the right results from it. So for example, if I increase the velocity from 70 kilometers per hour to, for example, 90, then I need to bring the right results. And now you can see here the fluid pressure, fluid shear stress, XYZ, they came to the simulation. Create a mesh. I'll create a very nice fine mesh here. So I will click on mesh parameter option. Put that parameter 0.2. Takes a bit of time, but it should give me a really nice mesh. And if you want to refine the mesh, you can use mesh control, and you can apply some techniques what we learned in the FEA analysis. So mesh is finished. Okay, came reasonable, not bad, but you can improve it better, and you can do mesh test analysis. Now since everything is okay for me, run this study. This study would take a bit of time, so I will pause the video and then wait for it to finish. If it's up here a message for you, just say no, keep running the simulation, and here is trying to perform the simulation. That simulation we done it with fast, so I didn't investigate or evaluate the contact between the two parts or the multiple parts. So definitely you can do that, and you can investigate the results in a good way. So I'm waiting for the Solvbot to finish the results, and then soon we'll start investigating some of the displacement and some of the outcomes. If you want to work in this model, you can modify and make some changes to it. Now you can see it's already will start loading the things. Definitely nothing will happen to the Jeep like that, so just click on deform results to avoid that shape. That's just the software is exaggerating the results, and you can always come here to this result, and you can see it didn't exceed this tensile or the stress, and make that to megapascal, and make that as well floating. And now you can see the results in a better way, which is reasonable. And you can also click on the displacement, and you can see everything from this. For Mesa's results, like if you can see the values, actually it's not reading what you anticipate, because possibly it's not showing much of the stresses applied. So I could really just change the value for the maximum and minimum. So if this is the minimum value is 0, the maximum, I could say let's see what happened when the maximum is 0.01, and then you can see how it's changing the concentration to look to the Jeep around it. Yeah, that's all what we're presenting today. And sometimes the results are not realistic, so if you see there is nothing, no pressure on the window, but you can always investigate something, define vector or define stress plots, um, and then you can select the parts you are interested to investigate. Definitely you need to have a better like selections as well to make sure whatever is happening to this screen based off the speed uh, of the Jeep. That's all. Thank you.